here we're beginning by asking to write the factored form of x squared plus 14x plus 49. Okay, is there a GCF? That's the first thing I always look for when I factor. Well, 7 works for 14 and 49, but it doesn't work with 1, which is the first coefficient. So it's 1, and do they all have an x? No, so there is no GCF. No GCF. Second, is this a special case? Well, maybe, but we don't know what they are yet. So third, how many terms do we have? 3. Is this in the form of ax squared plus bx plus c? So we can do the a times c method. So here, that would be 1 times 49, which gives me 49. So let's list the factors of 49. Well, 1 times 49. 2 doesn't work. 3 doesn't work. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 times 7 works. So which of these multiply to be 49 but combine to be 14? 7 and 7. How convenient. X squared plus 7x plus 7x plus 49. Now we group the first two together and the last two together. What's the GCF of the first two terms? Just an x, which is going to leave me with x to the first plus 7. Close your parentheses. The GCF of the last set of parentheses is a positive 7, so we need to put plus 7. And what's left when I factor out a 7? It's going to be x plus, if I factor 49 from 7, that's going to be just 7 left. Remember, we divide. 49 divided by 7. So this factors to be what's in front of the parentheses. X plus 7. What's the matching parentheses? X plus 7. This factored to be x plus 7 times x plus 7. So we can write this a little differently. If I'm multiplying x plus 7 times x plus 7, we can write that as x plus 7 squared.
What I struggled with yesterday was double negative. It's like x squared minus 14x minus 14. Yeah, yesterday was just bad. Get back.
So here, is there a GCF? No. So is it a trinomial? Ax squared plus bx plus c. Yes, a times c. 9 times 25 is 225.
Someone say 25.
So what can multiply to be 225? 1 times 225. Will 2 work? How do you know that? Because it's odd. 2 doesn't work. Does 3 work? Do you know how to know if 3 will work as a shortcut? Do you guys know how to tell? No.
Yeah.
You can. But here's how I know. But that's right. You can do 225 divided by 3. But I don't have a calculator. So if I don't have a calculator, here's how I know if 3 works. I add the digits. 2 plus 2 is 4. 4 plus 5 is 9. Can I divide 9 by 3?
Yeah.
So I can divide 225 by 3. That's the shortcut for 3. That always works.
Where the crap did you bring that out?
Well, I learned that when I was in 8th grade, 7th grade.
They teach you that?
Yeah, they taught us that.
Where are you going?
I went to Plainview, so
We ain't learned
I know this is divisible by 3. So I know it's 3 times, and then 225, that's going to go 21 is 7, 15, 5. I did 3 goes into 2, it doesn't. 3 goes into 22, how many times? 7 times. I can do division in my head. 7 times. 7 times 3 is 21. I subtract 21 from 22, that's 1. Bring down the 5. 3 goes into 15, 5 times. I know if 2 doesn't work, no other even number will work. So there's no point in trying 4. If 2 doesn't work, 4 won't work. 5 works, why? Because it ends in a 5. Do you guys know that rule? Okay.
No, I just do math. I just don't remember all this stuff.
225 divided by 5 is 45. So that's your option. I mean, you could just do it the long way.
I did.
But I'm trying to teach you some of my shortcuts now, and your response is, well, I'm not going to remember that. Well, then you're not learning it. I mean, this is why I'm stuck in this. I give you extra time. Okay, next. 6. Do you know how to know if 6 works? 2 and 3. If 2 and 3 both work, 6 works. 2 didn't work, 6 won't work. Does 7 work? I know no good tricks for 7. So I just have to try it. 7 goes in there, 21, 15, 7 won't work. 8 won't work because it's even. 9. 9 works. So if I do 9 times 25, right, is that going to combine to be 30? No. Still not. So I got to keep going. 10 won't work. 11 doesn't work. 13 doesn't work. 15 should work. 15 doesn't work?
Well, yeah, 15 times 15 does. But
15 times 15? So can I combine 15 and 15 to give me 30?
Yeah, but it's a negative thing.
Okay, so I need to combine negative 15 and negative 15. That goes back to integer rules. Y'all guys don't know
That's right.
if I'm at negative 15 and I lose another 15, I keep going more negative, right? So I'm negative 30 now. So I could rewrite negative 30 as negative 15x minus 15x.
For some reason I was thinking it had to be negative 15x minus 15x.
So if it was a negative and a positive, this last one would have to multiply to be negative. Because a negative times a positive.
There's 2 negatives.
If they're 2 negatives,
That's when you do.
then they have to be opposite signs.
Okay,
If they're both negative.
I had it backwards.
If this is positive, they have to have the same sign. Right? That's what I kind of have here. If C is positive, my 2 factors will have the same sign. If C is negative, the factors will have different signs. One positive, one negative. Now we group. GCF is 3x, which leaves me with, when I factor that out, 3x minus 5. GCF here is negative 5. That leaves me with 3x minus 5, which means this factors to be 3x minus 5 times 3x minus 5,
So it'd be 3x minus 5 to the second.
which we can write as 3x minus 5 to the second.
So like,
Coops, why are we doing the squares?
It's like, it's just like a sim, it just makes the answer shorter, really.
Makes the answer shorter.
So you still have to go through all this.
How will we know to put in the square version or the other one with 2?
If the parentheses match, you have to write it as to the second. So I'm going to start working this one. First thing I'm looking, is there a GCF? No. Is it a trinomial, ax squared plus bx plus c? Yes, so we can multiply a times c. 4 times 9 is 36. Now what multiplies to be 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Now I need them to combine to be 12. So it's going to be 6 and 6. Which means I can write this as 4x squared plus 6x plus 6x plus 9. Everybody good so far? Group the first 2 together, group the last 2 together. The GCF of the first 2 is 2x. When I factor that out, I'm left with a 2x plus 3. The GCF of the last two is a positive 3, which leaves me with 2x plus 3, which means this factors to be what's in front of the parentheses times the matching parentheses, which is 2x plus 3 squared, or to the second. Same thing. So, first thing I'm looking for, is there a GCF? 1, useless. 2, is this a special case? So here's the special case we're looking for. It's called the difference of squares.
That's different.
So what does difference mean? I'm subtracting. So am I subtracting here? It's a difference of squares. Is this a perfect square? Yes. Is this a perfect square? Yes. So anytime you have a difference of squares, it factors to be the square root of the first term. So what's the square root of x squared? X, because x times itself. So in the front of my parentheses, I'm going to have an x and an x.
Oh, I think I know where this is going.
Take the square root of the last term. What's the square root of 9? 3. So it's going to be 3 and 3.
Is it not minus? Yeah.
We have to alternate the signs.
Oh.
One positive, one negative. That's it. It's factored. It's a special case.
So if there's just two, you just take the square roots?
If there are two terms that are being subtracted, and the first and the last are perfect squares,
So what if
all that has to, well then you can't use this. You can't do it perfect.
What do you do if it's not perfect?
Well, we haven't got to how to factor two terms when it's not,
So that's
you can't. There's really only two ways you can factor it if there's two terms. There either has to be a GCF, or it has to be a difference of squares, or you're going to learn about, not this year, difference of cubes, sum of cubes. There's some more special cases.
Cubes?
But for two terms, it either is a GCF or a special case. Okay? And so right now, this is the only special case you know for two terms. Remember, how can I check this work? Do you guys remember? You could distribute. Right, this is just me checking. So what was x times x? X squared. X times negative 3. Negative 3x. 3 times x was positive 3x. 3 times negative 3 is negative 9. Do I have like terms? And those combine to be what? 0. They cancel out. Do you guys remember doing this?
Yes.
And what was left was x squared minus 9. And I told you, notice how the first term is a perfect square and the last term is a perfect square. And I told you we just changed the sign between them. And we called those, does anybody remember what we called these? When you multiply two things that look almost the same, but the sign is different between them. It was a funny word. It started with a C.
Khan Academy?
Conjunction.
Conduits.
Conjugates. We talked about it just for a second. They're conjugates. All right, let's go kind of quickly here. Factor. It only has two terms. First thing I'm looking, is there a GCF? Is there a GCF? No. Is this a special case? Well, is it a difference of squares? That's really what I'm looking for. I'm subtracting, so it's a difference. Is this a perfect square? X times X. Is 64 a perfect square?
Yes.
So I can factor this to be the square root of the first term, the square root of the last term, 8 and 8, and we alternate the signs between them. One positive, one negative. Difference of squares.
Does it matter which way you put it? It's like, it's the difference.
If you put minus and then plus, that's fine. They just need to be different. One positive, one negative. Here, we're looking at this one. Is there a GCF? GCF.
Wait, 2x, no, 2.
3x and 10.
So, it's not there's no GCF.
Oh, no, I was thinking
There is no GCF.
the squaring thing.
Is this a special case? Yes, we have a difference subtraction of squares. 9 is a perfect square. X squared is a perfect square. 100 is a perfect square. So if this is a difference of squares, this factors to be
3x plus 10.
the square root of the first term, which would be 3x and 3x. The square root of the last term, which is 10. And then we alternate the signs between them. So first thing I'm looking for, is there a GCF? Yes. Yes, there's a GCF.
3x, y.
The GCF is 3x to the first, y to the first.
Yeah, because that goes in there.
Right? 3 and 12 have a factor of 3. If I can go up to the third floor and the first floor, what's the highest floor they both can reach? The first, so that's x to the first. And here the first floor and the third floor, highest floor they both can reach is the first floor again. So 3xy. Everybody good with that being their GCF? Now what am I left with?
You will be left with.
Well, if I factor a 3 out, the 3's cancel.
So it's
If I factor,
3 squared.
there's no
I
3.
mean, x squared.
X squared.
Y would cancel out. 'Cause
The y's cancel.
X squared.
X squared is it for the first term.
And then minus.
Minus. If I factor 3 out of 12, I'm left with a 4. If I factor x out of x, cancels. Y out of y to the third.
Y squared.
So I took my GCF out.
I don't like these problem scoots.
Now, question so far, GCF. Now, still looking at what's in parentheses. Is this a special case?
No.
Is this the difference of a perfect square? X squared a perfect square?
Yeah.
Is 4 a perfect square? Is y squared a perfect square? So in parentheses, I have the difference of squares.
Would that be 3 different terms then? Since.
This is the GCF that is out front.
Yeah, okay. No, I'm talking about 4y squared. Since it's both. They're
It's
both
2 terms.
squares.
2 terms.
So how would you.
So now, the GCF just comes down. We don't mess with the GCF again. It's just going to be part of our answer in the end. But now, what was in parentheses, we said that's the difference of squares. So that factors to be 2 parentheses. What's the square root of the first term? It's x. What's the square root of the last term? 2y. 2y. And when it's a difference of squares, we alternate the signs. One positive, one negative. Factored. Number 1, is there a GCF?
No.
There definitely is.
What?
This is even and this is even. So I know at least a 2 will come out.
Yeah.
All right, will a 3 work? No. What about a 4? 4 doesn't work with 50. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. I think it's going to be 2. So if I'm not sure if a higher number works, I know 2 will, I'm going to factor a 2 out. If I factor a 2 out, that leaves me with 25 x to the second minus 16 y to the second. Now I can check again. Does these numbers have a GCF? No. So I got the highest one to start with, which was 2. Now, I took the GCF. Next thing, is what's in parentheses a special case? Is this a difference? Is this a perfect square? Is this a perfect square? So I have the difference of squares, which means the 2 comes down. And this factors to be the square root of the first term, which is 5x, and the square root of the last term, which is 4y. Alternate the signs.